In this video, I'd like to discuss multiplying exponents. And I'll explain what happens to exponents when we multiply terms that have the same base. For example, 2 to the second power multiplied by 2 to the third power. Now, I recommend that you watch my video on calculating powers if this is something you're not yet familiar with. Now, as you can see, both terms have the same base. And this means that this expression can be solved a couple ways. One method that can be used to solve this is by raising 2 to the second power. This means I need to multiply 2 copies of the base, which equals 4. And next, I need to raise 2 to the third power, which means I need to multiply 3 copies of the base, which equals 8. And last, I need to multiply both answers, 4 and 8, which equals 32. So 2 to the second power multiplied by 2 to the third power equals 32. And now I'd like to demonstrate another way to solve the same problem. Now remember, in the first example, for the first term, I raised the base 2 to the second power, and for the second term, I raised the base 2 to the third power. And I then multiplied both answers. Well, since I'm multiplying copies of the same base, it really isn't necessary to have 2 terms, since I'll be multiplying 2 copies of 2 and then multiplying that by multiplying 3 copies of 2. In that case, it would be more simple to have one term with the base 2 and to take both exponents and add them together. So I'm going to add the exponent 2 and 3, which equals 5. And I'm going to raise 2 to the fifth power, which means I'll multiply 5 copies of the base, which equals 32. And as you can see, both methods give the same result. So let's apply the second method we used to help simplify the next problem. 4x to the fourth power multiplied by 5x to the fifth power. Now, I do recommend watching my video on multiplying algebraic terms if this is something you're not yet familiar with. But when multiplying algebraic terms that are not alike can be brought together. And to do this, I'll first multiply the numbers 4 and 5, and next, I'll multiply the variables x to the fourth power by x to the fifth power. So, let's start by multiplying 4 by the number 5. And 4 multiplied by 5 is equal to 20. And next, let's multiply the variables x to the fourth power by the variable x to the fifth power. And remember, since we're multiplying several copies of the same base, which is x, we can simply write one term with the base x and take both exponents and add them together. So I'm going to add the exponents 4 and 5, which equals 9. And since x is an unknown value, we can't raise x to the ninth power, and we can't multiply 20 by x. So 4x to the fourth power multiplied by 5x to the fifth power has been simplified to 20x to the ninth power. Okay, let's try simplifying one more expression. And like the previous expression, I'm going to start by multiplying the numbers. And next, I'll multiply the variables. So let's start by multiplying 2 and 4. And 2 multiplied by 4 is 8. And next, let's take the answer 8 and multiply it by the next number in the expression, 6. And 8 multiplied by 6 equals 48. And next, let's multiply our answer, 48, by the next number in the expression, 5. And 48 multiplied by 5 equals 240. And now that we've multiplied all of the numbers in the expression, let's multiply the variables. Now remember, when multiplying terms with the same base, we can add their exponents. Well, the terms x and y are different letters because they represent different values. This means we can only add the exponents of the variables that are alike. So let's first solve the terms with the variable x. So that is x to the third power multiplied by x to the seventh power. And remember, since we're multiplying several copies of the same base, which is x, we can simply write one term with the base x and take both exponents and add them together. So I'm going to add the exponents 3 and 7, which equals 10. And next, let's solve the terms with the variable y. Now, you'll notice the first y term doesn't have an exponent. Now, a number or a variable that appears to have no exponent really has an exponent of 1. And the reason the exponent 1 is unwritten is because we don't really need to write it, since anything to the power of 1 is equal to whatever that number is. But in this case, I'll write the number 1 to demonstrate what we're adding. And again, since we're multiplying several copies of the same base, which is the variable y, we can simply write one term with the base y and take both exponents and add them together. So I'm going to add the exponent 1 and 4, which equals 5. And that's it. We've done everything that needs to be done to simplify the expression. If you like this video, please subscribe to Mr. McLean Math. And also, be sure to click all so that you get notifications when new math videos are uploaded. Thank you for watching.